Hi, everyone. Thanks so much for coming to this late end of the conference talk. Today I'm going to talk about some research I did into Microsoft Edge. I'm Natalie Silvanovich, and I'm a security researcher on Google's Project Zero. And you might remember, for the last year or two, I've been looking at Flash and found a lot of bugs there. Well, recently, I've started looking at browsers and trying to see if I can find similar bugs. So today, I want to tell you what happened when I looked at Microsoft Edge. So what did I actually do? I code reviewed the JavaScript engine of Microsoft Edge. We seem to have lost our slides here, but there's nothing too exciting on those ones anyhow. So I reviewed the JavaScript core of Microsoft Edge, and I found about 13 bugs, all of which are now fixed. It was actually the first time I'd looked at a browser in a long time, for about 7 or 8 years, and I discovered that JavaScript had changed a lot. So I want to share with you what I learned about JavaScript and how script engines are designed and how that impacts the type of bugs you can find in them. So to start off, I'm going to talk a bit about what Edge is, what Chakra is, and what ECMAScript is. Then I'll go through some of the more interesting features of JavaScript and script engines and how they're designed in Chakra. And finally, I'll give you some examples of some cool bugs I found. So to start off, what is Microsoft Edge? Microsoft Edge is the new Internet Explorer. It's the default browser on Windows 10. And Chakra is Edge's JavaScript engine. It's open source. You can find it online on GitHub. And it's constantly updated, which is great. You can actually go through and look at recent CVEs that have been fixed. It even accepts external contributions, just in case you want to be the change you want to see in Microsoft Edge. What is ECMAScript? ECMAScript is the JavaScript standard. When a developer creates a JavaScript engine, ECMAScript is the standard they implement. And everyone always asks me, why do you say ECMAScript when you really mean JavaScript? And the reason is that JavaScript is actually not the only implementation. The other big player in the ECMAScript world is ActionScript, which is what you write Adobe Flash Swifts in it. And also QtScript is also an ECMA language. So while JavaScript is probably most of the ECMAScript implementations, it's not the only implementations by far. And JavaScript is a constantly changing standard. There's been a lot added in the last couple of years, and they continue to release new versions. So now I'm going to go through some of the more interesting features of JavaScript, starting with arrays. Arrays, I think, are one of the most important features of JavaScript engine. I think, even if you've only written JavaScript once, you've probably used an array. They're used very, very commonly. And what's interesting about them is they seem extremely simple, but they can get really complex really quickly. So to start off, here are 2 arrays. There's 2 ways you can create an array. You can use the square bracket notation, or you can use the constructor. I like the square brackets, but just so you know what those mean. And these are very simple arrays. They only have numbers in them. And I would say most arrays used in JavaScript are arrays like this. They only have numbers in them, and they're very simple. But there's actually a lot more you can do with arrays. So this next array has strings in it, still kind of basic. You can also have mixed types in an array. So this array has an integer, a string, an object, and even a regex in it. And then next up, we have an array of arrays of arrays. And there's no limit to how many times you can do this. And you can even put arrays in themselves if you want. And then last, we have what is called a sparse array. And that means that it has missing elements. So there's the array D, which is 1, 2, 3. And then there's this element at index 10,000. And you can totally do that with arrays, and this won't cause the memory generally to be allocated. And just a terminology thing, when you look at a sparse array, the things that are empty between the first elements and the last element are called holes. So arrays can get even more complex, though. So not only can you have number indexes, you can also do array sub-banana or array.grape. And this is adding properties to the array, and yes, regardless of whether you use the property notation or the subscript notation, that does the same thing. But as another complexity, you can have a property on an array. And I'd say now at this point, we're up to like a really, really vast majority of arrays you see online use just these features. But it gets even crazier. So you can also have configurations on arrays. And that means you can make an array read-only, or you can even make a single element of an array read-only. So for example, this first array, the first element, element 0, you can only read. You can't write it. And then another thing, which I think is done a bit more commonly, is there is this freeze function that will make the entire array read-only, and you can't add any elements. And then there's other similar things like object.seal. So that's another complexity. But it gets even weirder. You can also add getters or setters to array indexes. So this array, when you try to read or write property 0, you will execute code, and for example, if it's a getter, that code will return what you get back from the array. So I don't think this is a very commonly used feature, but every single array has to support it. And then finally, you can also have array prototypes. And to explain what these do, if you look at how the class hierarchy in JavaScript works, you start off with the basic object of the array, which is the array object in this diagram. But then it has a superclass and a superclass, and there's no limit to how many times you can do this. So to start off, you have the proto-object, which gives it the array class. And this is where the array methods that you typically call in an array are, things like slice, things like index of. But then an array is also an object, that's the superclass. So you also have, the array has a proto to object, and then that gives you all the typical object features like toString. But what's even weirder here is, let's say you have an object with a prototype. That prototype can also have elements in it. And the elements can be as crazy as the elements in the array itself. So let's say we have this var array A, and then we're missing element 3. Element 3 is a whole. But then the prototype has element 3 defined, for example, this one. Then if you access element 3 of that array, it will actually go up the proto chain as far as it needs to, and then get the element from there. So I mean, that's pretty weird. And then also, you know, it could be a getter or a setter, it could be read-only, it could be a banana, it could be anything, which is interesting. So the other thing to realize is that all these different types of an array, all the basic array properties have to work on them. You have to be able to slice them correctly, you have to be able to splice, sort, etc., no matter how weird your array gets. So this is the challenge of the script engine designer. The reality is most arrays are very simple. Most arrays have only integers, and even after that, most of them only have simple properties, except there's all these out there features that could be used at any time. So what you end up getting is that every modern browser has multiple memory layouts for an array, and then they transition through the different types of array as needed. So here's how it works in Chakra. You start off with the simple array, which is an integer array. And then as soon as you add a float to it, it becomes a float array. And this is twice as big, because floats are twice as big as int arrays. And these are still in contiguous memory. And then let's say you add an object to it or a string to it. Then it becomes a var array. And that's the same size as a double array, except it's an array of pointers. And then the pointers are to each element. Even if it's an integer, it's now a pointer to an integer. And that allows this array to now have objects in it. Now this is most arrays, but now let's say you configure this array. You make it so that a property is read-only. Now it will become an ES5 array. And this is a dictionary array. It is a hash table for each element, and then that makes it so that there is pretty much no limit to what you can put in the array at the expense that it's no longer contiguous, so anything you run on it will not be as efficient as contiguous memory. Oh, there goes that excellent screensaver again. So how is this actually implemented? Well, in Chakra, they actually do vtable swapping. So to start off, this is how an array is laid out in memory in Chakra. It's actually a fairly elegant design because it makes it really easy to transition between sparse arrays and dense arrays. So to start off, you have an array, and this is an int array, and then the array elements are in this array segment. And this can be in line for a very simple array, but then there's just a pointer to it. And then for a dense array, you'll usually just have one of these, where it starts and where it ends. And then if it's a sparse array, then you'll add in something at next, and you can have as many segments as you want to have elements defined anywhere in the array, which is nice. So a dense array in Chakra is pretty much just a very small sparse array. The only way it becomes truly a sparse, truly a dictionary is if you configure a property, then it becomes a hash table. So then what happens when you transition between these two? To start off, it will just swap out the vtable so that it now points to the right vtable for the right thing. And then it will change each segment to be the right type, and then it will change the elements. This can realloc memory, but it doesn't have to. Sometimes, if it's short enough, it will just have enough space in memory to transition directly. And you can see how this is starting to be problematic. This is only safe at certain times. Your arrays can change a lot, so you have to be careful you don't make a lot of assumptions about how they work. So moving on, another important element is objects, and they're actually fairly similar to arrays, but they tend to be optimized for properties. So when you create an array, you're usually putting indexes 1, 2, 3 in them. For objects, they tend to have named properties in them, but they have all the same features as an array. They can also have indexes, they can also have accessors, they can have all this sort of stuff. And they can also be there's some exotic object types in Chakra. One that was kind of interesting is there's a deferred type. So in JavaScript, there's lots of different objects that need to be available at any time. For example, the regex constructor. At any time, JavaScript could create a regex, but it probably won't. Most JavaScript doesn't. So this would take up a lot of memory, except they have this deferred type. So the first time you access this object, then it starts loading it in memory. And this saves a lot of memory, but it adds a bit of complexity. And I would say objects in general are a bit less bug prone just because in arrays are often very large and they're optimized for being very large. Meanwhile, it's very rare to see an object that, say, has more than 100 properties in it. So here's how an object works. Once again, there's two notations. These are actually subtly different, but it's not that important. I usually use the curly braces where it shows the object and then what the properties of the object is. And notice with an object, like with an array, you can do all sorts of crazy stuff. For example, this is a pretty basic one. You've got a month and a day as properties. But then you can make the properties of the object indexes. So this is actually like an array. It has something at 1 and 2. And like with arrays, you can have objects with objects with objects, and you can also freeze them, you can make them read-only, that sort of thing. Now here's kind of a fun question. Let's say you have an array, and let's say you have an object, and you strip the proto off the object, so you can't just call a method to see which is which. And you can't call type of, and you can't call instance of. How can you tell which is which based on the functionality? And one thing you might say is, oh, well, you could call something like splice on it, and it would work on the array and not the object. But that's not true. All the array methods actually do work on an object if you call it on an object that has the right indexes and has a length and that sort of thing. So how can you tell the difference between these two? As far as I can tell, I can only think of one way, which is you set the length to banana. And you can do that on an object, but if you do that on an array, you'll get an exception thrown. And so that shows you kind of how fluid objects are in JavaScript. Yes, arrays are supposed to be used for one thing, and yes, objects are supposed to be used for another thing. But you get to the point where you can actually add so much stuff to both of them that it can actually be fairly hard to tell which is which. So what you end up getting in different script engines is what they call the fast path and what they call the slow path. And the fast path tends to be when things are normal, and there can be more than one, and the developers kind of have to pick what normal is. But that's like an optimized state if you're doing something that's fairly common and fairly expected. So an example is you might have a fast path for splicing an array that is all integers. And that's very optimized because it's limited. And these are good, but they can cause bugs because when you're saying, oh, well, are things normal? Are they in an expected state? You need to make sure that you've checked everything that can be unexpected in the state. And there's so many things you can do with JavaScript objects that can be really hard. And the other thing that the opposite of fast path is the slow path. And the slow path is the base case that is supposed to be able to handle everything. And these tend to be a little safer than fast paths. They don't have quite as many bugs, in my opinion. But then, once again, you're trying to write this thing that can, handle any case ever. But does it? You have to be very sure you're catching everything, and sometimes they don't. So now I'm going through a couple more features. Complex objects. So I've talked about objects, and I've talked about arrays. But there can also be special objects that are subclasses of objects, like a regex, a map, a function. And these need to have a different memory backing in C, because, for example, a regex needs a place to keep the pattern, and a function needs a place to put the pointer to the code. And they can also be extended. So in JavaScript, not only can you create a class that extends a class you created, you can also create a class that extends a regex. So this means that typing becomes interesting in JavaScript. Because if you think of how script actually executes, fundamentally, every object is some type of handle. And it's the handle you put on the stack, and it's the handle you put in a function as a parameter, and that's what's used for all sorts of things. And script needs to differentiate between all these different types, because a function, when it pulls a parameter off the stack or out of the parameter array, it doesn't know what type it is. So Chakra does this kind of two different ways. To start off, there's the actual values of the handle. And in Chakra, these can either be integers or they can be pointers. And this is differentiated by the 48th bit. So to give an example, if on the stack you're pushing integer 7, it will be this long 1007. And that has the right bit set to show that it's an integer. Otherwise, if it doesn't have that set, it's a pointer. So it could be a pointer to an object, or it could be a pointer to a regex. And then there's a second type check that happens. Let's say you need to do something that's just on a regex. Then that will have a field inside the object to tell the caller what it is, and that needs to be manually checked in the script engine every time you do something specific to that type. So one more thing I'll talk about, which I will say is fortunately not very interesting in Chakra, which is garbage collection. There definitely are engines where garbage collection is a problem, where stuff can be spuriously freed, but Chakra tends not to have this problem. The garbage collector is very conservative. It does something called stack scanning, so if you have a pointer on the stack, even if you don't have another handle to it, it won't free it. And there's also some exploit protection features, such as delayed free, which make things not freed very often. So, and I'm not joking here, my model for the Chakra heap is that nothing is ever freed. And so far, it's been good enough for the purposes of this research. So now moving on to some fun and exciting bugs. So I'm going to start off with this one. And this one is due to the ability to put a getter on an array, and it's in array.join, which is basically toString for an array. It's something that you put an array in, and it creates a string so that you can print it. So here is the proof of concept for this bug. You start off, you create your new array, and then you create this interceptor, this getter function on the array index, and then this function adds an object to the array, and then you call this join function. And this ends up causing an unexpected transition, which is problematic and makes it into an info leak. So if you look at how the code is implemented in Chakra, what happens here is that when you join the string, when you try and convert everything to a string and append it, it will go through the array length, and then it will call this try templated get item. And this is a templated function that assumes the type and knows the type based on the array you pushed in. Unfortunately, it doesn't handle array transitions properly. So when it calls this function and gets one of the indexes, in this case 2, it will actually call into this function, which will put an object into the array and then change the type and cause an info leak. So that's an example of how the ability to put a getter on an array can be problematic. Sorry, this is a genuine and a conference keynote. I have genuine conflu here. So here's another issue due to a getter on an array. This time it's an overflow, and it's kind of interesting. And it's in the spread operator. You can see the spread operator being called at the very bottom, q of ... t. And what this does is this makes an array into an arguments parameter. So if I call Q with ... t, when I get into Q, the arguments of my call will be the elements of that array. So in this case, I create an array, and then once again, I add a getter to it, and on index 3, and then this changes the length. And then I call the spread operator. And what happens here? If you look at the code, they kind of try and check for this situation. Right up front, they say, are the arguments that I'm copying too big for the array I'm copying them into? And if so, just throw a fatal error. That's good, but you can change the situation later. So the get length is actually safe. That's guaranteed to be a number, guaranteed not to be a getter or a setter. But when you get the item, that can call a getter or a setter, and then that can change the array length. So you can see this is just like a massive overflow. If you change the array length to be very large, then it's overflow your stack. And that's the issue with this bug. So here's another interesting bug, and this is a segmentation issue. So you know how I described the arrays as being lots of different segments if they're sparse? Well, you can imagine for certain functions in an array, it becomes quite difficult to implement them when your arrays are done that way. So this issue is in the reverse function, and you can imagine that reversing that sort of segmented array could be quite challenging because, you know, things from the last segment need to go into the first segment, and what if your segments change? Not a lot of fun. So this is a bug that involves, once again, an array interceptor, an array getter, and it basically changes the length of an array. And this one's a little bit of a picky bug. You can see I had to do some like very specific lengths, but the basic is that your array length is 1,000, and then you create the accessor on it. Then you call reverse, and then the accessor makes the array longer than it was before. That's the interesting part. So then you can see what the problem is here. You start off by getting the length of the array. And then this function, reverse, does something called fill from prototypes. Because, you know, reversing is already a bit of a nightmare. And it's even more of a nightmare because you have to realize arrays can have prototypes that can also have indexes in them. So you can imagine if you were trying to fetch everything from the proto every time you accessed an index, and you didn't even know that was there before you were trying to reverse it. That would be very problematic. So the way they try and handle this is they try to get everything out of the proto before they call reverse. So they'll go and iterate through the proto and make sure that if you have, say, element 3 on the proto of the proto, they copy it into the current array, so now that element is in the array. So they do that, but what they don't anticipate is that this can change the length of the array. And then this becomes basically a simple overflow. If your array was big, what was small and is now big, now this can overflow, and you can end up with this huge length, and this will eventually overflow again and become basically an overflow in one of these segments. So, you know how I said I had told you all the weird stuff about arrays? I totally lied about that part. There is one thing that is actually there's a few more, but this is the most interesting of the things that are even weirder than the stuff I already talked about. So this is a feature of JavaScript called array.species. And the idea of this is that, let's say you call a function on an array, and let's say it's a function that returns an array. So like, let's say it's something like filter, where filter will take each element out of the array and then run a function on it, then put the return value into a different array. Now, you've got this array you get back. Now, is that array an array, or is it a subclass of an array? And what the ECMAScript standard has to say about this subject is, why don't we do both? So you have the symbol species on the array class that you can redefine and add a constructor. And then this will be used to construct the thing that your array gets copied into. And of course, this is easily implemented by putting an extra script call into every single function in native code. So it ends up causing a lot of problems because it's kind of an unexpected feature, and it really gets into like the guts of every single array function that has been there for years already. So here's an example. So here's a bug in array conversion due to array.species. So to start off, you create this array, and notice this is a mixed type array. It has, an object, an array, and my name in it, and then you call filter on this array. Except you've also set array.species. So this causes problems when you actually create an array. So in the implementation in Chakra of array.filter, it starts off by calling array_species.create. And this creates the array that all the filtered stuff is going to be copied into. But notice what it actually does here. It returns this array, the one at the top, which is an integer array, which is totally not the same type of the array that you're copying out of. So it does that, and now you have this int array. And then you eventually get down to the bottom here, where it gets the item, it calls the filter, and then it tries to put the item back into the array if it returns true. But wait a sec, this thing is the wrong type for the array you provided. So that's type confusion. And it happens because this function did not expect that the array returned would be anything but the type of the one, anything different from the type of the one that was provided. So here's another weird feature of JavaScript, the proxy. And the idea here is, what if I want to debug JavaScript in JavaScript? What if I want to debug JavaScript in JavaScript in JavaScript? So it tries to create an interceptor for absolutely everything you can imagine. There is nothing you can do in JavaScript that a proxy cannot intercept. It can intercept get, it can intercept set, it can intercept, enumerating, really anything. And this can also be problematic in some situations where the developer might not be expecting a property. And it's especially interesting sometimes when it's the prototype the prototype of an object, because it can lead to lots of unexpected things when doing the fallback, when getting an element. So here's an example here of a bug in the shift operator. It's actually in that get element, the prototype filling that I showed in the reverse thing, but I'll show that to you again. So you've got your array, and then you've got this proxy, and one of the many, many things that a proxy can overwrite is getting the prototype of a function. So you've got the array, you've got the proxy, which is the prototype, and then the proxy's prototype is this code that will get called to return future prototypes. So then you've got this special object, and then you call shift on it, and what happens? Well, it starts off by calling internal fill from prototype, and this is once again trying to get all the elements from the protos into the main array, because shifting it would be extremely painful if you had to iterate through the array many times. So it does that, but it makes an assumption about the prototype you get back. And that's because in Chakra, only var arrays, and I'm guessing at ES5 arrays as well, can be the prototype of an object. If it's an integer array, it converts it to a var array just to avoid this type of problem. The thing is, when the prototype is the proxy, the prototype can dynamically provide the next prototype, and there's no checks done on that. So in this case, it is an int array. So when it tries to copy those elements from the int array into the var array, they aren't correctly typed, and you end up basically overwriting pointers with integers, which I think makes this an especially bad bug. So here's another fun type of bug. So the slow path. Everything I've shown you so far has been on the fast path. They're optimized ones. But there's also slow path. And slow paths can be challenging to write because they need to handle every single case ever you can imagine. And it's getting to be a more popular thing that slow paths are actually written in JavaScript, which actually makes a ton of sense because, you could probably write a pretty good slice pretty quickly in JavaScript. And it would 100% work all of the time because JavaScript always takes the getters and setters into account anyhow. So that's becoming more common. It's pretty foolproof, but the one problem that can come up is that user code can alter its behavior sometimes. You have to be really careful that users can't, or you can often end up messing up memory. And sometimes script engines use strict mode to prevent this, and it does help, but it's not perfect. To give an example here, this is just my imaginary built-in function that is a slow path in script. And it's called do built-in stuff, and then it creates an object, and then it adds a property to the object that's an object, and then it freezes the object, and then it does a native call on the object, on this object O that it's created. So what are the problems here? Well, there's two. One is, what if I put a getter or a setter on the object prototype? So this is the object prototype that is used on every object, even objects that haven't been created yet, because every object points up to that default prototype object. And if you change that, that will change it for every single object, even objects that you create later. So if you do that, and you make this prototype so that stuff has a getter or a setter on it, then when it calls o.stuff, it's going to call your function, and then you can get a handle to the object. And that can be problematic, because maybe this native change stuff assumes something about it. For example, it probably assumes that stuff is an object, because that's what it put in. So this is kind of a cause of problems. And then there's a second thing, which is that you can redefine functions in JavaScript. And so let's say you overwrite object.freeze with this function, and then you call the other function. Once again, you can get a handle to that object O. And the other thing is that it probably doesn't freeze it correctly either. And either of those can be problematic for this native function that gets called later. So this, I think, is kind of an emerging area of bugs. I think as more slow paths get added in JavaScript due to lots of crazy ECMA features, we're going to see more and more bugs like this. Chakra uses less of what I call host script than a lot of browsers. It only does internationalization for slow path in script. But I think this is like a problem in the long run that's going to get worse and worse. So here's an example of a bug in internationalization due to this lack of type checking and the ability to tamper with script. So here's the code from Chakra. In the host JavaScript, so this isn't my JavaScript, this is Chakra's JavaScript, you can define a property called collator, or they define the property called collator, and this is, if you've ever used internationalization, it's a way you can compare strings in different languages, in different typesets, and make sure they're compared correctly. So this is like regex, or map, or function. It's supposed to be something that is defined by the script engine unless you change it. And then in script, it gets a property from it and does all this stuff to it without type checking. So the problem here is, let's say I define the very same property on an object, and then I create the object. Remember how I told you about deferred types in Chakra? Well, internationalization happens to be a deferred type. So you start up, and you call international.number format, or international.collator, and then this will kick off the creation of this internationalization object. It will make the deferred object try and become a real object. And when it does that, it tries to execute this script. And when it does, you've already created that object, and then it will call your getter on that object instead of the default object. And then you can change this native object before this next code gets called. So what that does is that allows you to change all these types that they assume are objects to things like integers, and this ends up being type confusion. Even though these objects on the stack have that one set which make them the number type, it's not checking here. So that means you can confuse pointers with objects. And then I'm going to show you pretty much one last fun bug here, which is simple error. So I'm going through a lot of complex bugs here. And sometimes bugs do happen due to lots of complexity. But sometimes bugs just happen due to sheer error, and this is one of them. So this is in a SIMD function. Actually, I'll show you the POC first. This is also my favorite bug just because I can tweet it. It's the right number of characters. And this is just a fall through. So when you have a very large number of parameters, where very large is 3 larger than 3, it just falls through. And I'm pretty sure this was a mistake. They meant that assert to be something that was not an assert, maybe a fatal error or something like that, but that is not what happened. And this falls through, and this is an uninitialized variable. So that's about it. To conclude here, I think I've learned a few things here. One is that JavaScript has a lot of features. It has an excessively large amount of features. Like, I think I've only described about 2 features here, and it has like 1,000 more like this. But it's something I think really important, regardless of what you're developing, even if it's not a script engine. Every one of these features adds bugs. And you really got to think about, are these features worth it? And I know the people that make browsers don't write the browser standards, but for example, with the array.species, how often have you ever used that? How often have you added an array index interceptor to your array so you can add a getter or a setter at an index? Like, I know I have never done this, not in a bug. So I think that's a big lesson here, that a lot of these kind of obscure functions do add bugs, and I think you've got to decide, are they worth it, or are they not? Another thing is that implementation decisions, they affect what kind of bugs you have. And I'm not trying to, be down on anyone who writes code. Like, these are super hard problems, and there's no right choice here. Any way you implement this, there's going to be trade-offs between basically performance and security and ease of development and many other things. But it is really important to be aware of this stuff, to make sure that you understand that your choices of do you do a fast path, do you do a slow path, that sort of thing is really important, and it changes the type of bugs you have and also many other features of the engine. So as developers, I think it's important to think about that in the design. And I think as bug finders, it means that it's really important to understand the design and understand how it impacts security. Both from the side, if you're looking for more bugs, I think figuring out how the main features works. I didn't think it would lead to quite as many bugs as it did end up leading to. But really, just a good understanding of how things are implemented really does help find bugs. And from the securing perspective, I think it's important to understand this so that you know what to avoid. Once you know that certain designs lead to certain bugs, certain problems, I think that's the first step to trying to prevent them. So that's it. Thanks a lot, and please feel free to ask any questions.
Thank you very much, Natalie. Any questions from the floor? No? Well, she'll be at the party as well, I believe.
Yeah, but I also have my contact info if you want to email me or something.
All right. Thank you very much, Natalie.